In these two examples, we're going to do two examples that are going to relate doing derivatives of sines and cosines. So just a quick refresher, derivative of sine is cosine, derivative of cosine is negative sine, and derivative of any is going to have a negative to it, whether it's cosine, cotangent, or cosecant, there'll be a negative something. We did the previous two problems basically involved something that had a trig in it, and they ended up having some product rules as well. This time we got a quotient rule. Any of these things, I would look to see if I can simplify it by chance to make it a little bit nicer. Again, if I can simplify something out of a quotient rule, I'm going to try, but I can't on this one. So I just got to deal with the derivative on it. So, all right, so here is our derivative. We're doing the derivative with the quotient rule. So we're looking at the derivative of the top. So derivative of 1 is 0. Derivative of sine is cosine. So derivative of the top times the bottom minus the top times the derivative of the bottom. So the derivative of the bottom is derivative of 1 is 0. Derivative of sine is cosine, so a negative cosine. All right, so there's our derivative. And then that's the top part of it, and then the bottom squared. All right, so probably not much I'm going to be able to do with this. Let's see what we can do with this. Now the algebra kicks in. So we'll distribute. So we have a cosine x minus a cosine sine. And then I have a negative that I would distribute, but I also have a negative that I would distribute. So let me go ahead and cancel those to make sure we know that that's actually a positive that's going to be there. So that's going to be a cosine and then times this one. So I see that I have a sine cosine. I want to keep it in the same order because I don't want to write sine cosine and then it feels different than cosine sine. They're really the same thing. So if I went cosine times sine on this one, I want to be consistent just to make sure I don't miss it, that they're going to be like terms. All right, so there's my distribution over this. 1 minus sine x squared. Let's see, I have a cosine and another cosine. So we have 2 cosine x. And I have a negative cosine sine and a positive cosine sine. Those are going to cancel each other. So there's your top. Here's our bottom. 1 minus sine x squared. And that is the derivative of that original problem. All right, so let's do one more. We're going to do derivative of tangent. Right, so eventually we're just going to have some properties for this, but I want to show you where this property that we're going to do, like all of them, the derivative of tangents and cotangents and secants and cosecants, we're going to have just kind of these properties that go with it. But before we get there, we're going to show you where this thing comes from. So if I'm going to be looking to do the derivative of tangent, and I don't know what it is, so I can manipulate this, though, into the derivative of, I'm going to sub out tangent with sine over cosine. Now, I do know the derivatives of those. So unfortunately, though, when I do that, I create a quotient rule. But eventually we're going to know that derivative of tangent is just going to be a value. It's going to be kind of a memorization, and I have a way to kind of help that cause. So, but let's do this one. Let's actually show where this answer is going to become. So it's going to turn into secant squared, and that's just something that eventually you'll know. Let me show you how. So if we do this derivative, we're going to do the quotient rule. So it's going to be the derivative of the top. So the derivative of sine is cosine. Derivative of the top times the bottom minus the top times the derivative of the bottom, which is negative sine. So derivative of cosine is negative sine all over the bottom squared. All right, so there is our step. Here is now our algebra. slash trig to kind of manipulate this stuff. So we have cosine squared. And then we have a negative and a negative, so that's going to turn into a positive. Sine times sine is sine squared. And then that's going to be over cosine squared. Now, before I go crazy on trying to cancel things, I actually have this perfectly set up right here of that is one of our Pythagorean trig identities, that's a 1 over cosine squared. And that's not the only way to manipulate this. You could have written this as cosine squared over cosine squared plus sine squared over sine squared, and then you'd have a 1 plus tangent squared, which manipulates into something else. But I think it's a little cleaner to just kind of recognize that this turns into a 1. A better way of writing this, so I don't have a fraction, is going to be converting that into secant squared. So the short of this is the derivative of tangent is always secant squared. And then on the next video, we're going to talk about what all of those other trig identities are, or the trig values other than sine and cosine, and a way to help remember them. All right, and then we'll do some examples for it.